we obtain? That means unknown. Then it says we start with 16 grams of this, and we start with 48 grams of this. And they're asking you how much we can get. Okay, there's really no shortcut. Most people cannot do these in their heads, and here's why. You might think this is excess just because you got more grams. Not necessarily true, because you've got different formula weights for these two guys. You've got different coefficients in front. There's too much going on to just say, oh, that one must be an excess and forget about it. No, you can't do that. So here's what you got to watch for. If you see a problem like this and they tell you about two reagents, that should send a red flag up. Okay, be on high alert. It is a trick. And the safest way to do this, work two-weight weights. Absolutely independent of each other. Take this as the known, and this, of course, is always going to be the unknown. We'll go through it once. Then we're going to come back. Absolutely separate problem. We're going to work it again. And we're going to see which one gives us less product. Okay, so ignore the oxygen. Yeah, Bruce?
Why is it that we're trying to find out the less product?
Because...
Oh, okay, that makes sense.
Okay. Now, what formula weights will I be needing as I go through here? Pedro, what do I need? What formula weights should I...
16.0 grams per mole.
Okay, for the methane. What other formula weights will I need?
For the oxygen, it's going to be 32.0 grams per mole.
Okay.
And for the CO2, it's going to be 44.0 grams per mole.
Excellent. We're going to need 3 of them this time. Okay, so we're doing number 1. Meredith, tell me what to put in this first set of parentheses.
You put the mole and
Okay, but I got 16 grams of it. See, they gave me bad units. They gave me some nice numbers, but they gave me bad units. So how do I switch that? You've got to have moles here, so what should I do? Okay. You know what? Okay. You know you're working with 16 grams, but we need moles here. Okay. How can I change 16 grams into moles?
or divided by formula.
Divide by formula weight. Okay. 16 grams. I think if this had been anything other than 16, she would not have been confused. So this is 16 grams per mole. You go, hooray, the math is easy. But it is, see, did you notice how that little twist made it more confusing? It just happened, what they gave you for the known just happened to be the same as the formula weight. And that was confusing. Okay, but we got to do this to get it into moles, so you may have just jumped to that. Stick in 1 mole of methane and roll with it. Okay, then I need mole ratio. Liz, what's it going to be?
1/1.
1/1. So we have 1 mole of carbon dioxide for every 1 mole of methane. Good. Now let's go on to grams here. So Alex, what do I need to do next?
Multiply by the formula weight of CO2.
Okay. 44 grams per 1 mole. Okay, Nina, I spread that out. I could have put grams/moles. And see here, unit analysis. Moles here came around on the top, cancel with those moles on the bottom. Moles of CO2, cancel with moles of CO2. That gives me grams. And let's think about proper number of sig figs and units, and let's punch that through. Charles, what did you get?
44.
It's just 44, isn't it?
Yeah.
Okay, that turned out to be 1 times 1. Still 1 times 44. We would get 44 grams of CO2. Okay, if this is a multiple choice question, I can absolutely guarantee one of the answers is going to say 44. Just because it rolls up on your calculator doesn't necessarily mean it's is the right answer. What it means is if I get to use up every bit of methane I have because I've got enough oxygen, I could make this.
That's right, I will eat anything.
Now, we need to go back down through it. Now we're going to do the second one, which is independent of the first one. Okay, for this one, Eddie, what do I put in the front thing here?
48 over the formula weight of the unknown. No, of the known,
Which is,
32.
yeah, it was right there for you. Grams per mole of O2, which is going to switch this into moles of it. 48 divided by 32, which is where you are right over here. You got grams and you need moles, so we divide it by the formula weight. Okay, then we come over to here. Tanya, what's my mole ratio?
1 to 2.
1 to 2. Now, did you hear what Tanya first said? She had that inverted, but she quickly realized it was a mistake and she turned that around. So you want to be sure. What if we kept it what she first said? Grams and grams would cancel, moles of O2 would come up on the top, and we would not have moles of O2 to cancel with. So it's always unknown over known. The one and only place we use coefficients. And then here in the last, Nicole, up front, 44.0 grams per mole of CO2, and now your moles of CO2 cancel, gives us grams. Let's punch that through. Sarah, you got it? 33.0
grams of CO2.
Okay. Now, multiple choice test. Don't say the answer yet, but let me give you some choices. Answer A is 44.0. Answer B is 33.0. Answer C is the sum of the two. Answer D is the difference of the two. Answer E is the average of the two. What do we really get, Pedro?
Is it going to be the limited?
Yeah,
D?
we're going to get that. As soon as you see these two numbers, the answer is always the smaller of the two. Always, always, always. Which means that this was excess. The smaller number of grams were actually excess. That this, with more grams up front, is limiting. That's why you can't just eyeball it and know. You gotta go through the work. Now you could save yourself a little tiny bit of trouble if you just got to moles of this and moles of that. You would know, but you still got to take it on and get to grams, so you just as well do it this way. Okay, so here, let me talk this through one more time, just quickly. If I get to use up all 16 of these, I could make 44. But my oxygen shows me, if I use up every bit of oxygen I've got, I can only get to 33. Okay? So it's like this business over here. It's not quite as straightforward, because here you can just look at your original numbers, and these react 1 to 1, and this is like you're already in moles type of thing. So,